Section 6, Systems of Linear Inequalities. Systems of linear inequalities. A system of linear inequalities is made up of two or more linear inequalities. A solution of a system of linear inequalities is any ordered pair that makes all of the inequalities in the system true. We're kind of combining two different things that we've talked about so far in Chapter 6. This is the final lesson. It's kind of wrapping both pieces of Chapter 6 together. So we've talked about systems of equations. We've also talked about linear inequalities. Now we're combining those two ideas. Remember, systems of equations, we had three different ways to solve them. We could use elimination, substitution, or graphing. And then we've had linear inequalities where we have a linear inequality. We graph a line using either a dashed or a solid line, and then we are going to shade either on top or bottom of that line, depending on what the inequality is. What we're doing now is we're taking two or more linear inequalities, and we're trying to solve for both of them simultaneously. So we're combining these two ideas. Which method of solving systems do you think we should use? We have graphing, substitution, or elimination. The only way that we can solve a system of linear inequalities is by graphing. What we're going to do is we're going to graph and shade each inequality in the system in the same coordinate plane. Where this shading overlaps is where the answers are to the system. So we're going to graph and shade one linear inequality. Then we're going to graph and shade the other linear inequality in the same coordinate plane. So both of them will be in the same coordinate plane. Wherever the shading overlaps the other one, that is where our answer is. My suggestion would be to, first of all, shade fairly lightly. Secondly, if you have colored pencils, I would go ahead and I would choose two different colored pencils, two different colors, so that you can tell really where those shadings are overlapping. Let's go ahead and try a couple. This says, what is the graph of the system? We have two linear inequalities. We have y is greater than or equal to 2x minus 1, and then we have x plus y is less than 2. Notice I've gone ahead, there's a red dot and a blue dot. That's just notation to tell me which line is which. My first step would be to graph and shade the first inequality, y is greater than or equal to 2x minus 1. It's going to be a solid line. It has a y-intercept of -1, and then the slope is 2 or 2 over 1. So this would be my first line. It says y is greater than or equal to, so I need to shade above that line. So there I have my red solid line, and I'm shaded yellow on the top of that line. Then I have the next linear inequality, which is x plus y is less than 2. This one is not in slope-intercept form yet, but I can put it in slope-intercept by subtracting x from both sides, which would give me y is less than -x plus 2, which means my y-intercept is at 2, and then my slope would be -1. This is going to be a dashed line because it's just less than. It's not less than or equal to. And I would need to shade below because y is less than that line. Notice where the two shadings have overlapped are right here. So these ordered pairs in the green are solutions to this system. Where it is just shaded yellow is not a solution to the system of equations, and where it is just shaded blue is not a solution, but it's where it's been shaded by both the linear inequalities, so by both the yellow shading and the blue shading. So only the ordered pairs in the green are going to be solutions to this system. The next says we have 4x plus y is less than 2, and we have y is greater than -2. I can go ahead and solve for y in the first equation by subtracting 4x from both sides. So I'd have y is less than -4x plus 2, which means my y-intercept would be at +2. My slope would be -4 over 1. So I would have this line right here, which it would be dashed because y is less than. My slope is negative 4 over 1. My y-intercept is 2. I would shade below this line. Again, I've shaded this one yellow. It doesn't really matter what colors you choose. The next equation is pretty nice. I have y is greater than negative 2. Graph the line y equals negative 2. It's going to be a dashed line again, though. In this case, I would need to shade above because y is greater than that line. So this area right here, where both the green, where both the blue and the yellow shadings are overlapping, those ordered pairs in the green are going to be solutions to this system of inequalities. In this example, they've given us a graph and they ask what system of inequalities is represented by the graph. I need to look at each line and shading separately, and I can write the two inequalities that combine to make this system. Let's look at the solid line first. I know that it's going to be, first of all, if you look at the shading is above this solid line, and it's a solid line. So I know y is going to be greater than or equal to, and then I need to find the slope and the y-intercept of this line. The y-intercept is negative 2. The slope would be 1 over 1, so just a 1. So I would have y is greater than or equal to x minus 2. Remember, a slope of 1, it's not necessary to have 1 in front of a variable. So there's the understood 1 there that's telling me the slope is 1. For the dashed line, if you look at the shading is below this dashed line. It is a dashed line, so I know it's just going to be y is less than. My y-intercept is still at negative 2, but in this case, my slope is a positive 1/3. So this inequality would be y is less than positive 1/3 x minus 2. This last example says a dog walker earns $15 per hour. She also earns $12 per hour for babysitting. She wants to earn at least $300 next week, but can work no more than 30 hours. What is a graph showing how many hours she can work at each job? I have two different inequalities that I can write here. First thing I need to do is I'm going to say let x be the dog walking and let y be the babysitting. The first inequality that I could write is that 15 times x, or $15 per hour when she's walking dogs, plus 12y, which would be $12 per hour for babysitting, has to be greater than or equal to 300. I can also write the inequality x plus y, remember x is the hours of dog walking, y is the hours of babysitting, has to be less than or equal to 30 because she can only work no more than 30 hours. I need to take that first inequality and go ahead and solve for y. To do that, I would subtract 15 on both sides and then divide by 12, so I get y is greater than or equal to a negative 5 over 4x plus 25. Go ahead and graph both of these linear inequalities. This would be the y is greater than or equal to negative 5 over 4x plus 25. To graph this next linear inequality, I would need to subtract x from both sides, so I would have y is less than or equal to negative x plus 30. And I would need to shade below that line because y has to be less than. So this strip right here would be the solution to this system of linear inequalities. One thing that I want to point out is that I've only included the first quadrant in this graph. The reason why is that it wouldn't make sense to have negative numbers in this situation. You cannot work negative hours at a job, at least these kind of jobs, the dog walker and the babysitter. You can't really work negative hours. You're either working and making money or you're not working and not making money. There is no negative here. So that's why I've only graphed in the first quadrant for this problem. Today's assignment is on page 428. It's numbers 1 through 20 all.